Yeah. Hi, good evening, everyone. Welcome to our event. I'm Sanchi Dhamija, the program coordinator for this event. Our next speaker is Mr. Jatan Mehta, who works as an independent space exploration writer and is the contributing editor for the Planetary Society. His works have been globally published, and he also publishes his works in a newsletter titled as Moon Monday, a newsletter dedicated to all new and upcoming things in the space sector, space exploration, and discussions pertaining to returning humans to the moon in this decade. All of his writings can be found at blog.jatan.space. Today, he shall be shedding some light upon lunar exploration, coordination, and sustainability. We welcome you, Mr. Mehta. You now have the floor.
Thank you, Sanchi. Just a sec, let me pull up my slides here. Okay. So can everyone see my slides?
Yes, we can see.
Okay, great. All right. So first of all, thank you to Moon Village Association India as well as to Susmita for recommending and suggesting that I do this talk. So I thought about, what I could contribute to this uh, keynote today and to this larger celebration, especially given that compared to the other four speakers, I am the least experienced and I'm still in my learning phase. So I thought long and hard about what I could, bring to the table that would be unique and you could take something out of it. So my idea is I will share, roughly speaking, 4 to 5 things which will highlight specific points. And those points are with what I hope that you would be able to think more about and reflect on and find information on. So with that, let me begin my talk. Sanchi has already introduced me here, so I will not gloss over that, but I will mention that uh, everything that I mention in my talk uh, going ahead now, you can find background information for all of it on my blog and elsewhere on the web. So you could, get that extra information out from these sources highlighted here and beyond. All right. So the first thing I wanted to highlight was my talk is titled "From Chandrayaan to Artemis," and it's meant to highlight a few interesting things, starting with the Chandrayaan mission and culminating in the currently happening Artemis efforts to send humans back on the moon by NASA. And so Chandrayaan 1 was a very special mission for India, and not simply because it was the first interplanetary mission that we had undertaken or any planetary mission of that sort, but in fact, Mangalyaan is the more popular mission that everyone seems to know about. But personally, I think Chandrayaan 1 is more important. And part of it has to do with the collaboration model used for Chandrayaan 1. So most people do know that, or at least have heard that Chandrayaan 1 is what found water on the moon. And that is true. We did find water on the moon. But what most people do not know is, or it's worth remembering, that we confirmed water on the moon. The hints for having water on the moon were always there since the last 15 years, at least, prior to Chandrayaan 1's launch in 2008. So it goes all the way back to the Clementine mission by NASA at the least, whose radar saw indirect signs of waterized deposits on the moon's poles. However, the data in that mission, from that mission and earlier missions, were not sufficient to confirm that it really is water and not, highly reflective rock, for example. So with Chandrayaan 1, there was a clear objective both from ISRO's side and its partners that we should be able to confirm water on the moon, given that so many missions prior have already hinted to the same. Um, and so what ISRO did was had a few instruments of its own, including the Moon Impact Probe, which Gracio mentioned earlier. Uh, they had that instrument in order to confirm water on the moon by themselves, as well as ESA had an instrument which would indirectly map water on the moon using a neutron spectrometer. and there were NASA's two instruments. One was a NASA M3, the Moon Mineralogical Mapper. It's an infrared spectrometer, and the other was a radar by NASA called MINISAR. And both of these instruments detected hints of water, but it was particularly the M3 instrument that confirmed water on the moon. Uh, Now, how and why is something you can web search on your own. But what I wanted to highlight here was that so it was not as if people were completely unaware of the possibilities of water on the moon before Chandrayaan 1. However, we should obviously give credit to the spacecraft for this, for confirming water on the moon. And but at the same time, also acknowledge that it was NASA's instruments on the spacecraft that helped confirm the discovery. So it's a core discovery, and it's something that it's a good thing. I mean, we should be proud of such collaboration. Now, when I use the term collaboration, I am referring to a very broad sense of it, unlike how Susmita highlighted the nuances of collaboration earlier in her talk. So for the purposes of this talk and the context I'm trying to get at, I'm going to be as broad as possible and try to see collaborations as positive signs wherever possible, which certainly in this case I think is one of them. In any case, so with that discovery, now I have also seen a lot of people on the internet think about Chandrayaan 1's discovery of water on the moon as the reason why NASA and now China and Russia and many other agencies of the world are going back to the moon. That's just not true. I mean, even if you look at the planning of various space agencies across the globe before Chandrayaan 1, including NASA's Constellation program, which at that point was not cancelled, by the way, and even by other agencies and so on. China always had their own plans. So what Chandrayaan 1 did was accelerate the pushback, the renewed interest in the moon. It did not create the interest, but it definitely catalyzed it. So that's another finer thing that I wanted to say, which is usually not very clearly understood, or there are misconceptions about the same. So Chandrayaan 1 definitely catalyzed our return to the moon. And when I say our, I mean plans by countries globally, not India or US or anyone else specifically. So that's one thing. So, but as a result, we could, so do you see the second slide?
Yes.
Yeah, okay. The renewed global interest one.
Yes.
Yeah, okay. So yeah, so now this is just a very small sampling of how much I could fit from various countries, of the kind of projects they are having. So on the top left is NASA's Sustainable Lunar Architecture Plan, which is debatable, but nevertheless, it's the best shot that any country is ever giving to this effect. So that should also be credited at the same time. Then there's China's and Russia's initiative for collaborating for a future scientific lunar base called ILRS, International Lunar Research Station. So that's on the bottom left, and then there's in the bottom middle, European Space Agency's Large Logistics Lander. Now that is a particularly interesting bit for me. It's not talked about very much within space circles or even the moon circles for that matter, but I think the intention and premise behind the project is something to ponder upon. So the European Large Logistics Lander, EL3, what it does is Europe is not at a stage where it's even developing that lander yet. So no metal has been bent, not a single metal has been bent yet for the project. However, from the current planning and the detailed design reviews and so on, that it has basically given to Thales Alenia. But based on that and based on the intention behind EL3, what they are trying to do is develop a large logistics lander, it's in the name, which is capable of carrying about 10,000 kilograms of cargo to the surface. And this is uncrewed cargo. So this is either scientific payloads that you may want on the moon, or a large rover for that matter, which you can see in the illustration here. and so on. So this is a supporting lander. So what ESA is saying is that, which is very symbolic of how ESA usually operates. So what ESA is saying here is that whoever goes to the moon with crew, be it NASA or in principle China and Russia. This is before Russia's invasion on Ukraine. But what ESA is saying is that with this lander, what we will do is we will provide the logistics and cargo support for crews on the moon by no matter what agency, right? And that's a very interesting proposition to me. Now, if they are able to have a high flight cadence for this lander and have high reliability, and they are also having precision landing built into the system, which will be very critical for the moon's poles, where you have a very rocky terrain and very few areas with sunlight. So it's really critical to have a precision landing of less than 100 meters in error. And this is what they are intending to do from the get-go. So I think that would be interesting. And then there's JAXA's pressurized rover, which they are proposing to NASA, offering to NASA in return for carrying Japanese astronauts to the moon. And then there's Chandrayaan 2 lander illustration as a reference for the future Chandrayaan 3 and the joint Japanese ISRO mission that we are planning with LUPEX and so on. And then there's Starship, which is, I'm not yet sure how to categorize it, because if it turns out to be anything like the Falcon 9, it could be used both for US purposes, which is obviously going to be there because they have been selected for landing the first Artemis crew on the moon, but also for if it's a Falcon 9 type vehicle, then it could also be, just used as on a commercial basis. So if someone based in Europe wants to send their instrument on a lunar starship, they very well could in the future. So that's a interesting model right there, and so on. So there has been renewed global interest in the moon, and this time around, at least there are far more agencies participating than during the Cold War era. Like, even if now, to Susmita's point, even if now our intentions globally for returning to the moon may not be very pure, for the lack of a better word, but nevertheless, comparing to the Cold War era, it is a much needed step forward on an overall basis. But at the same time, we obviously should consider every step of the way what is the right thing to do and how policymakers come in and so on. So what the other thing I wanted to highlight here is that South Korea is nowhere in this particular illustration, and so are not many countries, because there's only so much I could fit in here. However, South Korea is an interesting. So I'm on the next slide. Can you see that?
Yes.
Okay. So South Korea is a very interesting example here for me, at least, because South Korea is at the beginning of its planetary exploration endeavors, just like India was about 13 to 14 years ago when we launched Chandrayaan 1. So in that sense, South Korea's lunar orbiter is very similar to Chandrayaan 1, and the similarities do not stop there. So with this orbiter, what I wanted to highlight is, just because, like, I've seen discussions in forums, especially on Twitter, which is like just about the worst place to have any genuine discussion on the internet. But what I've seen essentially is people say that if NASA is going to land humans on the moon, or anyone else is going to do anything of that scale, then why even bother with these smaller projects? Or what is the larger point of these smaller projects if they do not grow at a fast pace? So what they are essentially saying is, if South Korea wants to, and I'm just using South Korea as one example, what they're saying is, if South Korea wants to launch a spacecraft to the moon and have a moon program, it should be a very fast-paced moon program in order to do great things. But I would disagree there completely, because the impact of a space mission is not merely the mission itself. Case in point being Chandrayaan 1. So when Chandrayaan 1 launched in 2008, I was just 14. Like, I'm, as I said, I'm the least experienced person on this panel. I was just 14. I was a child, like in school, and I heard about Chandrayaan 1, reading in newspapers and seeing it on TV. And I was very excited about it. And I always used to read NASA missions, like about NASA missions in whichever source I could find. But Indian missions were obviously rare. And an Indian planetary mission was a new thing altogether. So what I did was uh, read about the mission, and I was very excited about it, more so than the usual excitement that I had with NASA missions. But the more important thing was I noticed in people around me who were typically not interested in space at all were starting to show interest simply because it was an Indian mission, so they could relate better. Now, this is not meant to be a nationalistic comment. I am not a nationalist, but there's being able to relate is a different thing altogether, right? So I saw many Indians being able to relate to Chandrayaan 1, and that was a beautiful thing, and that is what partly made me take space exploration as a profession. And then the discovery of water came in. That is when I realized that okay, even we as a country who are just beginning in our planetary exploration endeavors can contribute big things on a global scale with small missions which are cheap compared to anything that NASA or ESA does. So that was also a very striking thing for me, and it really inspired me that okay, this is something worth pursuing for our country, and this is something I can also start looking at as I grow in, you know. So with South Korea is about to launch their first lunar orbiter called the Korean Pathfinder Lunar Orbiter. They recently named it Danuri, and what that means in Korean is enjoying the moon, which I think is pretty nice. So South Korea's first orbiter is about to launch on August 2, so about just 2 weeks from now, and it is going to be the Chandrayaan 1 moment, right? So people in South Korea are about to have their first planetary mission, and they, I'm sure, will be more excited about it than many missions, even if they have been following space news. And this time, the other similar thing to for KPLO with Chandrayaan 1 is that it is actually building on the Chandrayaan 1 model. So Chandrayaan 1 had instruments from NASA, ESA, and some other countries within Europe as part of the mission. And that is what gave so many discoveries. It was proof that you can increase mission science without increasing mission cost. And at the same time, because we were collaborating with NASA and ESA and learning from their heritage of planetary missions, they taught us how to build state-of-the-art instruments for planetary missions. And we can see that in Chandrayaan 2. The Chandrayaan 2 orbiter has one of the finest instrument sets in the world. And that is definitely thanks to the Chandrayaan 1 experience of collaboration. So with KPLO, South Korea is doing something similar. They have one NASA instrument on board, which is called ShadowCam. Um, and what it will do is it will map permanently shadowed regions on the poles. These are regions which do not see any sunlight. They have not seen sunlight since about 2 to 3 billion years at least, because they are in a topographic low. So because of the geometry of the poles, they basically cannot, they do not have sunlight, and therefore you cannot see within them. But this very highly sensitive camera can detect reflected light coming out of those dark regions, which might have been reflected inside from the terrain outside of the crater, for example. And this instrument will basically give us the absolute best look at permanently shadowed regions on the moon till date, at a resolution which is not been seen before. So it's about 1.7 meters per pixel, which is just about the size that you need to plan a surface mission inside these dark regions, which is where the water is, and which is what we would want to know if we want to plan anything there. So if we are going to talk about sustainability and extracting resources of the moon, no matter what the purpose, scientific or otherwise, we need to know at least what the uh, terrain of these regions even looks like, and where are the boulders and so on. So KPLO is going to give us that thanks to ShadowCam. And at the same time, there are 9 NASA scientists on board the KPLO project. So they are also collaborating for helping get more out of the instruments on KPLO. So this is KPLO really seems resonating to me as a rehash of Chandrayaan 1 in a good way, right? So that's what I wanted to highlight, that it doesn't have to be a huge mission, it doesn't have to be a crewed landing, it doesn't have to be a sample return. Something as simple as this can have a very long effect on a country and what they are capable of doing, and international collaboration and so on, right? Now, the second last example I wanted to give you is of myself, in the context of how I could contribute to the ongoing debate or research in uh, lunar exploration. So, as far as the debate part is concerned, I do not participate directly, in the sense that I do not participate in policy issues directly, or anything of that sort. But I have a newsletter called Moon Monday, and what I do there is essentially give you a brief of everything that has happened every week. Say, for example, this tomorrow's Moon Monday will give you everything that has happened since the last Monday in lunar exploration, science, and commercial developments from all countries across the globe. So I'm not going to be limited to just NASA or ESA or so on. So I try to bring in as many developments as possible. And this newsletter is read by over 2,000 people, and that includes many people from NASA, ESA, ISRO, and so on. It also includes people from space companies, etc. Now, the reason I am pointing that out is, if these are the people who are reading, these are the kind of people who are reading the newsletter, then it means I have an opportunity to uh, uh, bring a point in that they might not have potentially considered, or at the very least transport a point from one place to another. So if someone out there is saying something interesting, which I happen to spot as a writer, because we sort of have this immense scan base that we have of the internet, of whatever we are tracking. So if I can just merely have that point come in and blast it out to 2,000 people of very relevant nature, then it might be something that they consider or reconsider, right? So case in point being this particular slide that you are that I hope you're seeing. So yeah, this is a slide of a permanent, the top left image is a permanently shadowed region shot by NASA's LRO spacecraft, which is their moon mapper, basically, since the last 13 years. And the bottom left is the result of applying some sort of an AI imaging processing algorithm to the crater, to the image, to bring out its features. So, for example, you can see some small craters in there, and you can very barely make out some boulders. So, if you see the right image in the slide, um, you will see certain boulders out there, and that's a scale that's very relevant, because if you want to plan a landing or a roving mission inside these craters, then you need to know this sort of terrain information. The top right part of the picture is just what you see if you use only an LRO image, but the top bottom right is what you see if you use this algorithm. Now, I happened to come across this research work by these few researchers. These are just like 4 people, but they're doing this excellent work. So I wrote about this in my newsletter. And the next thing I know is a few weeks down the line, some people in ISRO who also read my newsletter, they caught notice of this particular research, and they thought, hey, the Chandrayaan 2 orbiter has a higher resolution camera than the one on LRO, simply because it launched 10 years later. But nevertheless, it's a better camera than LRO has. And we could get even better information after processing this AI algorithm, right? And so they started using this for their imagery and now are identifying target sites. So this is just a very simple but effective example of how a writer who doesn't do research, who is not a scientist, who is not an engineer, can facilitate conversations around lunar exploration, or facilitate lunar exploration itself, right? So, like, this is for primarily the students and young professionals in the field, which I know, thanks to Gracio telling me that they are the bulk of the audience right now. So this is for you guys, that it doesn't, for you to contribute to something that you are passionate about, it doesn't have to be, a big thing, or it doesn't have to be at a big company. You can do meaningful things in your own right, once you identify something that you are capable of doing very nicely. So yeah, so that's the second last example, and now I have the last example because I'm running out of time. uh, yeah, so this is the last example. I spoke about this in relative detail in my newsletter again in the issue number 75, which I implore you to check out. But the brief of it is that NASA recently extended the LRO mission. It's a usual thing that NASA does, extends planetary missions which are healthy and functioning at their planetary destination. So LRO has been going on since 13 years now, and it was supposed to be a 2-year mission at its onset. Uh, and while there are some operational issues with LRO because of aging, natural aging of components in the spacecraft, it is still going fairly strong. And NASA has extended the mission by 3 years. So LRO will operate till 2025, at least, if not more, with some minor operational issues along the way. But nevertheless, they have identified a science and exploration campaign. If you look at the report, the NASA extension report, among which Alaro was one of the missions, if you find the report, it is public, by the way. So that report tells you what this LRO is going to do in its extended mission, and it is essentially going to be aiding the planning of landing astronauts on the moon. So it is going to try identify information relevant to um, people landing on the moon and the resources there, and what could be potentially worth looking into for future extraction, and so on and so forth. So LRO is going to be doing both a scientific and exploratory mission and trying to enable Artemis to happen. Now, the interesting thing here is NASA does have a very nice formal way of having collaborations in place for their missions, but in this particular report for the extension of missions, there was no mention of collaboration, even though it was being discussed in the meetings prior to the report. So that's a very odd omission, and I think that's a missed opportunity because uh, the Chandrayaan 2 orbiter, which we just talked about, it has it has double the resolution of LRO's main camera, and its other instruments are likewise upgraded in some capacity compared to LRO's instruments. So it is also a full-blown reconnaissance mapper, the kind that LRO is. So in that way, both the missions are very similar. They also have a similar polar orbit, which is great for mapping. So mapping missions typically have polar orbits. So it's also a very great mapper in a similar orbit. But there is absolutely no consideration even for having, for example, the Chandrayaan 2 orbiter, which is going to be at the moon until at least 2027, which is 2 more years than LRO, and about the time when the first astronauts will actually start to set foot on the moon, right? Because LRO might not be functional by the time 2025 end comes, and there is no follow-up mission planned by NASA. So if ISRO and NASA collaborate again on Chandrayaan, just like they did with Chandrayaan 1, there is a very good opportunity for Chandrayaan 2 orbiter helping figure out planning for Artemis, and it's not merely to serve Artemis. So, but there are also a lot of scientific exploration. There's a lot of scientific data to be found out at certain sites. So this is regardless of Artemis, but nevertheless, it would also aid Artemis. And from the point of view of NASA is keen on having India as a signee of the Artemis Accords, as was mentioned by the Vice President Kamala Harris a few months back in a press release by the White House. So NASA is keen on having India as a signee of the Accords. So a collaboration like this, wherein both the Indian science context as well as the orbiter and the NASA folks would both benefit, just like in the case of the original Chandrayaan 1 collaboration, would go a long way in positively affecting India's stance on the Artemis Accords and prove that uh, that Artemis Accords is actually meant to facilitate, peaceful collaboration on the moon and sustain as a result of it. So that's my time. I hope I didn't overshoot it a lot. I think, yeah, it's just 25. Okay. So yeah, that's my time. If you have any questions, I would like to take them, and I'll stop the share.
Thank you, Mr. Jatan, for your talk. It's the work you are doing in the field is amazing, and I would recommend everyone to go check out his blog and subscribe to his newsletter. Mr. Jatan, can you see the chat? We have a question for you.
Yeah, I'm just going through it. It was recently in the news that China is planning to set up a constellation. Do you think?
Yeah, above this is the follow-up.
Yeah, in fact. Okay, so this question is about. So as far as the constellations part is concerned, unfortunately, I'm not seeing that big of a collaboration. So if you look at, so just to back up a bit, if you look at um, the ESA's Moonlight Constellation Plan, which is a similar constellation and navigation service, and US is planning something similar with LunaNet. However, they are not advanced in their planning yet. ESA is farther ahead in this particular context, and China has just basically announced it in a very traditional fashion to them. But at the same time, what I'm not seeing here is any sort of a collaboration even being discussed between these three projects at the moment, which is firm. So that's a shame, I think, because a constellation network will essentially serve everyone. But I think this basically tells you about the kind of finer planning that these agencies are doing, but are not willing to share yet. But at the same time, I would say it's not a big deal breaker either, because I'm sure that just like the global navigation systems we have, which are somewhat interoperable and not that of a deal breaker in terms of a collaboration if everyone does their own thing anyway. So I think this is very akin to that. So it's not something I would worry about a lot. What I would be more worried about is the management of resources on the moon, as and when we find them, because that's the big question mark on how much there is, what should be preserved, not preserved, how, so on and so forth. So in that context, I would recommend everyone to check out work by the Open Lunar Foundation. It's a non-profit organization based in the US who do policy work, which is very important. And they present at the UN space exploration meetings, all of the relevant ones. And they are trying to determine models and bring policies to the table which could facilitate a level playing ground for using resources on the moon. So yeah.
Thank you. I think we have another question for you, if you can see that.
Yeah, would the region where Chandrayaan-2 landed be analyzed to find out what went wrong? Yeah, so this has already been found out. So the NASA's LRO spacecraft finally got an image of the Chandrayaan-2 lander's pieces. So basically, we do know that the Chandrayaan-2 lander crashed. However, ISRO has not been willing to admit that officially. And in either case, I think it's a missed opportunity. Like if the Chandrayaan, it should have been the Chandrayaan-2 orbiter showing us the image of the state of the mission, and it doesn't have to. I mean. I kind of get the some reasons for not showing that, but at the same time, I think it's not a good step in the right direction, personally, at least. So yeah. Yeah. Are there any other questions?
Yeah, I have another follow-up question with regard to the first question that you answered. So you were saying that it is not a deal breaker, there's no collaboration in the constellation work, but wouldn't that lead to more space debris around the moon if it is not tackled well? There's no
It would.
collaboration.
Right, it would. But at the same time, if you look at the number of satellites they are planning for such a constellation, at least in the case of Moonlight, where public information is available of some sort, the number is not that high. and you would, because moon exploration is growing, the number of satellites that you would have in orbit around the moon by various countries would anyway exceed that number specific to the constellation. So it would contribute to space debris in a general sense, but not uniquely, right?
Thank you for answering our queries, Mr. Jatan. I would again recommend everyone to go check out his blog and subscribe to his newsletter.
Yeah, so I just wanted to add there that, yeah, please do that, because most of what I do is writing, and anything that I say which is important is going to be in writing. So definitely subscribe. It's completely free of cost. There are no ads or anything. So I would really appreciate if you subscribe and even reach out to me. My email ID is publicly available on my blog. Please write to me. I love reading from people. I love getting in touch with them to discuss space and moon and all the things. So yeah, thank you for your time, and I'm sorry to have lasted a bit.